Welcome back. In this video, we'll be refreshing on some C++ concepts that will be important for us to remember while programming games in Unreal Engine. Now, if you don't understand these concepts already, I recommend that you take my Learn C++ for Game Development course. It starts at the absolute beginning and teaches you the basics of C++ and prepares you for all the coding we'll do in this course. If you do understand these concepts, feel free to skip ahead, but I encourage you to refresh on these topics just so you have them in your mind. Now, you can always come back to this lecture later to refresh on these topics once again. The majority of these concepts involve classes and inheritance. These are the main principles of object-oriented programming, and these are what give object-oriented programming its strength. Imagine that you have a C++ class. Now, classes have their own variables and also their own functions. And this class can be a parent to some child class, which derives from that parent class. So each child class will inherit variables and functions from the parent class, as well as possibly having its own child variables and child functions. Now, the parent class has the option to mark some of its functions as virtual. This means that child classes can override those functions, creating their own child versions of those functions. Now, the child can choose to call its own custom version of the function, its override, but it also has the capability of calling the parent version of the function. So it still has access to that parent version. Now, a parent class can have a child class, and a child class can have its own child class, and this can go on indefinitely. As long as a parent has a child, which has another child, and so on, you have what's known as an inheritance hierarchy, or also known as an inheritance chain. Now, a class can have many children. In fact, there can be many child classes that derive from the same parent. This happens all the time, so an inheritance hierarchy can get quite complex very quickly. A child class can also inherit from multiple parents. This is known as multiple inheritance. So in this case, each parent will have its own unique variables and functions, and the child class will inherit variables and functions from both parents. Now, when you have a given inheritance hierarchy, you might create a variable of type pointer to parent. A pointer is a variable designed to hold an object's address. So a variable of type pointer to parent is capable of storing the address of an object derived from the parent class. When a pointer stores the address of a given object, we say that it points to that object. A variable of type pointer to parent can point to an object of the parent class, but as you may know, a pointer to parent variable can also point to an object of a child class, provided that that child class inherits from the parent class. So our variable of type pointer to parent is capable of storing the address of an object of any type in this inheritance hierarchy as long as it's derived from parent, or parent at least exists somewhere up the inheritance chain. Now, the parent class might have a function, and thanks to inheritance, each child class lower in the hierarchy will inherit that function. Now, if this function is marked as virtual in the parent class, then each child class can have its own unique override of that function. Now, if you have a variable of type pointer to parent, and it's pointing to an object of one of the child classes, you may access the pointer and call this function. Now, the child override version of the function has the same function name as the original, the one that's declared in the parent class. So which version do we get called when we call the function? The answer depends on the object that our pointer is pointing to. Since the pointer is pointing to a child in this case, then when we call the function, we will get the child version called. So even though the pointer itself is a pointer to parent variable, it's the object pointed to that determines which version of the virtual function that gets called. This phenomenon is known as polymorphism. Now consider this inheritance hierarchy. Let's say we have a pointer of type pointer to child 1. And we call this variable first child. And let's say that we have this pointer pointing to a child 3 object. This is legal in C++. We can have a pointer to a parent class. In this case, child1 is one of the parents of child3, and the pointer points to an object of the child3 type. Now, let's say that child3 has its own function, which is not defined in the child1 class, and it's not an override. It's a function that belongs solely to the child3 class. We know we have an object of type child3, but we're storing its address in a child1 pointer. We can't call this function because the compiler isn't going to know that our object has this function. It sees that our pointer type is child1, and child1 doesn't have this function. So how do we call this child3 function? Well, what we can do is create a new variable of type pointer to child3, and we can make use of a special type of function called a cast. A cast will take our variable of type pointer to child1 and convert the type to pointer to child3. This cast happens at runtime, so it requires an ability known as runtime type checking, which means the object itself must be inspected for its actual type. If we're trying to cast this pointer variable to a child3 pointer, the object itself must really be a child3 object. In our case, it is. Now, if it is, the cast will succeed, and the cast function will return a value of type pointer to child3, which we can then store in our new pointer to child3 variable. If the object itself is not actually a child3 object, the cast will fail and return null. Once we successfully cast from child1 to child3, we now have a variable of type pointer to child3, which we can then use to call the function on the child3 class. Since we casted our pointer from child1 down to a child3 pointer, this type of cast is called a downcast. In C++, you've learned about static casts and dynamic casts. Static casts are performed at compile time and can be used when you know the types you're casting to and from at compile time, like casting an integer to a float, for example. But in this case, at runtime, we can't really know what our child1 points to, whether it's an object of type child1, child2, or child3. That can depend on what's happening in the game, as these are dynamically instantiated. So that can depend on what's happening in the game. So that's why runtime type checking is necessary, and this type of cast is known as a dynamic cast, since it can't be performed at compile time. Whenever we do a dynamic cast, it's important to check the pointer afterwards to make sure that it's not a null pointer, as this can be the case if the cast fails. Unreal Engine has its own inheritance hierarchy. Near the top of the hierarchy is a class called UObject. We typically refer to instances of this type as objects. Derived from the UObject class is the AActor class. We call these actors. Further down the hierarchy, the class APawn derives from AActor, and further down than that, the class ACharacter derives from APawn. Everything derived from UObject, which is not an actor, has U prefixed on its class name. That way we can take a look at the class name and know that it's not an actor, but a UObject. Everything derived from actor has its name prefixed with an A. So we can take a look at the pawn and character classes, for example, and know that they're inherited from the actor class. The UObject class is very basic. It can store data, but it doesn't even have the ability to be placed in the world by itself. That's how basic it is. The actor class inherits everything from the UObject class, but it has some significant upgrades. For one, it actually can be placed in the level, so everything you see in the game level is derived at least from the actor class or below. Actors can have a visual representation such as a mesh, and they have many more capabilities that we're going to learn about in this course. Pawns are derived from actor, but they have even more capabilities. The most significant, perhaps, is that they can be possessed by a controller. Now, a controller is a type of actor designed for controlling pawns. When you press the W key and your character moves forward, that's thanks to the fact that the controller is receiving your input, processing it, and turning that information into the action of moving your character forward. So since pawns can be possessed, this is a good class to choose for things that need to move around, based on some form of input, whether it's from a player pressing keys and moving the mouse, or input calculated by the means of artificial intelligence. Derived from pawn, we have the character class. Since it inherits everything from the pawn class, the character class too has the capability of being possessed by a controller. It also has more functionality, more suitable for bipedal creatures like humans. It has a character movement component, which performs all sorts of calculations related to moving characters. So characters are just special type of pawns that have more character-specific functionality as well. In general, if you need a very basic type of creature that simply needs to take input and move around, a pawn is enough. But if you want more character-specific functionality, you'll choose a character. Throughout this course, we'll be demonstrating that extra functionality that characters have once we create a character of our own. Now, the object, actor, pawn, character hierarchy is actually more complex than it looks here. There are many different classes derived from each of these. These are just several examples, but there are many more. Another important aspect of object-oriented programming is the difference between is-a and has-a relationships. Imagine you have a child class, and that child derives from some parent class. It's said that the child is a parent because the child inherits from that parent class, and this is why the child contains all the functions and variables that the parent contains, through inheritance. The parent, however, is not a child, so this relationship does not work both ways. Now, a child class can have its own child. We can call this grandchild. In this case, we can say that the parent is not a child, and the parent is also not a grandchild. And we can say that the child is a parent, but the child is not a grandchild. We can say, however, that the grandchild is a child and is also a parent. It inherits functions and variables from both the child and parent classes. Likewise, in the Unreal Engine class hierarchy, we can say that the UObject class, being the parent of the actor class, is not an actor, and the UObject is also not a pawn, but the actor, being a child of the object class, is an object, but the actor is not a pawn, and the pawn, being the child of actor, is both an actor and an object. This explains is-a relationships. Now let's discuss has-a relationships. Imagine you have a class, and a class can have its own variables. Some of those variables might be custom data types of various classes or structs. So inside your class, you might have a member variable that is itself another class. We can call the first class the outer class, and the variable contained inside of that class can be called the inner class. Now, the inner class can have its own variables, some of which themselves have data types of other classes and structs. So inside of an inner class, you can have an inner class. In Unreal Engine, classes are nested within one another quite frequently. At the outer level of a game project, you have a class called Package. Inside of the Package class is nested another class, and this class is called the World. Inside of the World class is nested yet another class, and this is known as the Level. Now, objects are placed in our level, and these are classes that are derived from actor or lower in the inheritance hierarchy. So a level contains actors. Now, actors typically have their own variables, some of which are components. Components are a type of subclass designed to be owned by actors, and they provide additional features that the actor can use. So an actor can have one or more components. So it's said that a package has a world, and a world has a level. A level has actors, and actors can have components. It's said that an actor component is a subobject of its owning actor, and the actor is a subobject of the level. The level is a subobject of the world, and the world is a subobject of the package. Now, there are some objects that are not nested inside the package like all of these classes, and these tend to be assets such as meshes, textures, sound files, and so on. So these are nested inside of the package itself, and we don't refer to these as subobjects. So now you've had a refresher on some important aspects of the C++ programming language, as well as a bit of an overview of the Unreal Engine class hierarchy. This information will come in handy when creating games in Unreal Engine. Keep these concepts in mind as we develop our game throughout this course.